Alright, today's lecture, mini lecture, talks about implicit differentiation. We've encountered functions, or you've encountered functions so far that can be described by expressing one variable explicitly in terms of another variable, right? However, our example, so in this example, in general terms, we have y equals f of x. But in this example, we'll need to we have some things defined implicitly by a relation between x and y, such as x squared plus y squared equals 25. Right, so here's our example. So we need to take care of this problem, and I'll show a different way on a separate mini lecture, but in this way I'll conduct it with implicit differentiation. So we're told to basically find dy dx, derivative of y with respect to x. So first we want to differentiate both sides of the equation, right? Take the derivative with respect to x of x squared plus y squared, and then take the derivative of 25, right? So we take the derivative of x squared plus y squared. We know the derivative of x squared is just basically using the power rule, so we get 2x. However, right here it's a different situation. We're taking the derivative of y squared with respect to x. So understand that y is a function of x. And also you see something squared here, so that tells you have to use the chain rule. So those two things, y is a function of x, and also we must use the chain rule. So the chain rule tells us that we can take the derivative of the outer, which is the something squared, which is 2, right? And the inner remains the same, which is the y, and then you subtract 1 from the exponent, which becomes y to the first. Then the chain rule says take the derivative of the inner. Well, the inner is the y, and we just said that y is a function of x. So everywhere we take the derivative of y, with y being a function of x, it's 1. However, it's 1 times dy dx. Right? So using implicit differentiation, whenever you're taking the derivative with respect to x, note that y is a function of x. So you take the derivative, but you still must use dy dx. Right? And we're taking the derivative of dy dx. Alright, so now we go on to the other side and say the derivative of 25. Well, that's easy. Derivative of any constant is 0. Right? So what happens next? Now we'd like to get the dy dx, the 2y dy dx on one side and the 2x on the other side. So basically we're solving for dy dx. So we'll have 2y dy dx is equal to negative 2x. Right? In this situation, let's scroll down a little bit. We need to solve for dy dx, so you'll divide both sides by 2y. So dy dx is equal to negative 2x over 2y. Right? So finally, dy dx, I'll write it over here, is equal to negative x over y. Right? So this is the implicit differentiation of x squared plus y squared equals 25. So we implicitly differentiated and got dy dx is equal to negative x over y.